The lecture today is going to be finding what they call empirical formulas, or you also see it written as simplest formulas. Basically what it is we did percent composition. You know, you've got a compound that's so much percent carbon, so much percent calcium, so much percent oxygen. Okay, we calculated that by taking the mass of the calcium divided by the total mass in the compound. So that's what we did last time, was percent composition. Now we're doing just the opposite. We're going to get the percent and we have to figure out the formula. And this is actually more common because if you find an unknown substance, you can run it through those fancy machines they have like on the CSI shows, you know, the mass spectrometer and infrared spectroscopy and all those fancy ones. And what they'll do is they'll tell you, okay, that compound is 43% this and 27% that. And so you can actually figure out what it is. The machines themselves actually have databases and they'll run through and they'll say, okay, that compound is cocaine. Because the thing about narcotics, about drugs, they're all made out of the same elements. They're just in different percentages. So, you know, if you do aspirin as opposed to cocaine, same elements, but obviously if you're, you know, have crushed up aspirin, you're not going to get in too much trouble as if you have crushed up cocaine. Things are going to be a little different. So that's what empirical formulas is now you get the percent and you have to figure out the formula. Okay? When you do that, it's what you do is you get the mass of the elements. You either get it in grams or you get it in percent, it doesn't matter. Then what you need to do is you need to find the moles. And to do that, all you have to do is divide by their mass from the periodic table. And then once you get that, you calculate a mole ratio. And what a mole ratio is you find the smallest of these numbers, put that on the bottom, and you divide each individual by that. The reason why you use the smallest number, you don't want to have a number less than 1. Because remember, when we do subscripts, they're always whole numbers. So we always use the smallest number and then divide. So the smallest number we're going to get is 1. And that will actually give you a mole ratio. It'll give you a number, and from that you can get empirical formulas. And I know that sounds a little weird, but I'll show you examples and it'll probably make more sense. Okay, we have a compound. It's called para-aminobenzoic acid. It's PABA. It's in, sometimes it's on your sunscreen. Sometimes it's like in your plastics. I think they used to say that on water bottles. Now it says contains no PABA, PABA. Maybe it's bad for you. I honestly don't know, you guys. Anyway, it's composed of 61.31% carbon, 5.14% hydrogen, 10.21% nitrogen, and 23.33% oxygen. What's its formula? Okay, so this is how we solve for it. What we do is we take that carbon amount. You can change, it can either be grams or percent, you guys. It doesn't matter. You'll solve them exactly the same way. So I'm going to take that amount they gave us, and I'm going to divide by 12. This is its mass from the periodic table. And this tells me how many moles I have. So take the percent they give you, divide by their mass from the periodic table, you'll get a number. You'll do that for all of them. Now, you guys, if you just want to use 12 and 1 and 14 and 60, I'm fine with that. You don't have to use 12.01 and all that. It's not a big deal. But anyway, you take the number they give you and you divide by their mass from the periodic table. And then these numbers, you look at them. Okay, here's my moles. I put the smallest number on the bottom, which would be this one. So I'm going to take this number divided by this number. I'm going to take this number divided by this number. I'm going to take this number divided by this number, which is going to equal 1. I don't need a calculator for that. And then I'm going to take this number divided by that number. So I did that on this slide. Okay? So you take the individual you got divided by the smallest moles. So this 7.005, again, you can round that to 7. 6.984, you can round that to 7. Sometimes they don't work out. Sometimes they like 6.5, and you can't round that to 7. And we'll talk more about that. I got an example to show you what you do there. But you get them close, because again, you're not going to write 6.98 in as your subscript. You're just going to write a whole number. So you get 7, 7, 1, and 2. So that's the formula. C7, H7, NO2. Okay? So again, you find the moles by dividing by their mass from the periodic table, then divide every one of the elements by the smallest moles, and then you get these numbers, and those are actually the subscripts. Okay, that's not so tough. Okay, here's another one. All right, we have a substance, and it was analyzed, and it was 89.14% gold and 10.8% oxygen. Okay, so again, first thing we're going to do is we're going to take that 89.14 and divide by the mass of gold. Gold's mass on the periodic table is 197. This is the bottom number. Okay, so we get 0.452. And then for oxygen, we get 10.8, that's its percentage, divided by 16. Now sometimes you guys, they give it to you in grams instead of percent. It doesn't matter. You solve them exactly the same way. Anyway, I got these two numbers, so I know my smallest number is 0.452. So I set up my ratios. 0.452 divided by is 1. And then I take this number and divide by 0.452, and I get 1.5. Okay? Now, I can't round that up to 2. That's too much rounding. Okay? But I have to have whole numbers. So what I'm going to do is I'm going to double them. If I double this one, it's 2, and if I double this one, it's 3. Now they're whole numbers. Okay? Maybe if this was 1.25, then what I have to do is I have to multiply both of them by 4. So you have to look at your numbers. You can't round. If it's like 1.9, that's not a problem. But if it's 1.5 or 1.75 or whatever, those you can't round. So you got to be careful. There's not that many that are that way, but you got to look at them. So we get 2 to 3. So since I can't write a decimal, I double both, and my formula would be Au2O3. That's gold 3 oxide. Okay? All right. Now that's for molecular compounds. Ionic compounds. Sometimes with molecular compounds, because we have a ton of compounds made out of carbon and hydrogen, or carbon, hydrogen, and oxygen. So if you have a molecular compound, there's another thing we look at, and it's called molecular mass, and I'll show you how to do those. Okay, so molar mass or molecular mass, after you find the empirical formula, some compounds actually have multiples of those subscripts. Okay, when we do empirical formula, it's the simplest formula. It is the smallest subscripts, but it might not be the compound for that formula or for that substance. Okay, this only happens with molecular compounds, especially carbon. Okay, you can have CH4, you can have C2H8, you can have, they're made out of the same substances and the proportions are the same, but they're different compounds. So organic compounds do that. That's why we have so many of them. All right. So this problem, all you have to do is do one more step, and I'll show you how to do that. Okay. So the empirical formula, let's say this substance, the empirical formula, we found the simplest formula, and it's CH2O. Its molecular mass is 180. So what is its molecular formula? Okay, so what I'm going to do is I'm going to take this number, the 180, and I'm going to divide by the mass of this one. We've got 12 plus 2 plus 16. The formula mass of this is 30. Okay, so I'm going to take 180 divided by 30, and it's going to equal 6. So what that means is, this is the multiplier of these, I'm just going to multiply all of these by 6. So my formula would be C6H12O6. Okay? So this is the simplest formula, or the empirical formula. But if you have to find its molecular formula, what you do is you take the mass that they give you. You'll always be given the mass. You can't figure it out without it. But you'll take that mass, you'll divide by the mass of this compound, of the simplest formula. In this case it was 30, and I got 6. So I just multiply everything by 6, and I get C6H12O6. So again, this is a molecular formula, and it's just one more step. When we do the percents and we divide by that, we're finding the simplest formula or the empirical formula. And sometimes, if it's a molecular compound, you have to add one more step. Here's another one. Okay, we have a compound that has a molecular mass of 42 grams and is composed of 85.7% carbon, 14.3% hydrogen. What's its molecular formula? Oh, so we do the simplest formula stuff. We take our 85.7 and we divide by 12, the mass of carbon. We take our 14.3 and divide by 1. Don't you just love when you use hydrogen? 1. 14.3. We set up our ratios, and we get, the smallest number, 7.14, divide them both by that, and we get a 1 to 2. So our formula is CH2. Okay, that's the simplest formula. Okay, now the mass of CH2, if you take 1 carbon and 2 hydrogen, is 14. It says up here its mass is 42 grams. So what I'm going to do is I'm going to take 42 divided by 14. Okay, that's 3. So now all I have to do is take this formula and multiply everything by 3. So C3H6. That would be its molecular formula. So its simplest formula is CH2. Okay, but again, because this is a molecular compound, we can have multiples of these. So again, you just take the mass they give you, and then you divide by its formula mass of the simplest substance. And again, I took carbon's 12 and there's 2 hydrogen. That's where I get the 14 from. And so that's my formula. Okay, that's how you do molecular formula. It's basically one more step. They're going to give you a mass. When you're done finding your formula, divide by its mass, and it's going to give you a whole number. Then just multiply all the subscripts by that number. And that's how you do molecular mass. So that's what we got for today. Empirical formulas, molecular mass. There is another, I'll have another video if you want, if I went too fast or confused you, for you to watch. And again, you have questions, let me know. But that's what we're going to cover today. Make sure you do your assignment after you're done. And I'll talk to you soon.